This is the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. This podcast series is sponsored by Allied Electronics and Automation, carrying the most automation and control brand names in North America. Now, the questions posed in this podcast series all come from automation technology users like yourself across the process and discrete manufacturing industries. I'm David Greenfield, Director of Content for Automation World, and the question we'll be answering in this episode is, what is functional machine safety? Now, to answer this reader question, we're speaking today with two representatives from Omron Automation, Todd Mason Darnell, Marketing Manager of Services and Safety, and Pamela Horbakovsky, a Safety Product Manager. Now, Omron supplies an array of automation technologies, from sensors and control and safety components to motors and drives, robotics, and power supplies. So, Pam and Todd, the term functional safety, it means that the automation protection systems on a machine work correctly in response to inputs or failures, whether those failures be related to hardware, software, or human factors. But what does it mean from an automation purchasing and implementation perspective for both end users and OEMs? And I guess to start with answering this, let's start with the end users first. When it comes to functional machine safety, how should they approach this from an automation technology perspective, whether they're dealing with their own in-house engineering staff, system integrators, or their equipment suppliers?
So in the United States here, for the end users, OSHA is going to be the huge driver for them on functional safety, right? And so you've got a whole bunch of different OSHA clauses. You've got OSHA 1910, 147, which is their control of hazardous energy, lockout, tagout. You've got OSHA 1910 212, which is their general requirements for all machines. OSHA 1910 219, which is power mechanic transmission apparatus, which really has to do with point of operation guarding. And then the all else fails clause is the OSHA general duty clause, which says OSHA instructs end users that they shall provide a safe workplace for their workers. And that's the clause that, requires that the end user really needs to look at machine safety among a number of other factors and ensure that the workers are not at an unacceptable level of risk when they're as an operator, right? So when approaching this, one of the things in dealing with OSHA and dealing with functional safety in the plant, we really recommend that an end user start to develop a safety strategy and a long-term safety strategy for the plant. What do they want functional safety to look like at their plant, and make all the stakeholders in the plant aware of it, especially the engineering teams and the manufacturing teams, right? Mm-hmm. And that really starts when they're looking at the hierarchy of controls, right? And when approaching functional safety, ideally from a machine design solution situation, you really want to eliminate the hazards if all possible. Design your machines or your process line such that you don't have a worker exposed to the hazard if possible. Only after that, then do you start approaching engineering controls, which is retrofitting safety, light curtains, hard guarding onto a machine to protect workers, right? And if all else fails, right, then probably what you need to do is start going to your PPE levels and your training levels, right? But we know that those are the least effective methods of protecting your workers. You really want to stay up there in their higher levels and either eliminate the hazard, put a robot in there, or put in some type of an engineering solution to protect your workers. Now, when you're approaching any system, the issue that many end users have is that there are many ways to skin the cat here. There are multiple ways to guard a machine to protect your workers. The problem that you get into there is that some are better than others depending on what your work processes are. So when you're looking at guarding a machine or a process line or coming up with a strategy about that, it's critical for these end users to involve all their stakeholders, especially those in production, on down to operators of the machines, and not just look at how those operators ought to run the machines, but how they're actually running the machines. Because if the engineering department comes along and implements a solution that interferes with production, as soon as engineering walks away, we know based on our experience that the operators and the maintenance guys are going to pull that solution off, and it's going to go off in the corner. And now we have a machine that everyone thinks is safe, but is actually unguarded. And that's a significantly greater risk to the operator than it was before, right? So anything that impacts productivity too much on the operators is going to get bypassed, right? Mm-hmm. And then what's really critical for these end users is they need to drive these specs to the OEMs, right? In the United States, right, as I mentioned, right, the responsibility for worker safety is at the end user. Most OEMs are not going to guard a machine, are not going to implement functional safety unless the end user specifies it on their equipment.
I totally agree with that. I think that one of the most important things to have in mind and to highlight is that a successful safety solution will depend on having a real good talk and conversation with the different stakeholders. So to have a complete understanding of the process, the machine, and to achieve that strategy.
Todd, you mentioned that OEMs won't specify this on their functional machine safety on their machines until or unless specified by the end user. So from an OEM perspective, what does functional machine safety, I guess, really mean to OEMs from an automation technology selection point of view?
I'm actually going to ask Pam to address a little bit more about that than she. That's a little bit more of her area of expertise than mine.
So when we're talking with the OEMs, there is a lot of additional value that they can deliver to the end user to have a more complete and competitive solution. So they could develop a good enough safety for the solution, and they could provide the basic things. So we're talking about just adding an emergency stop or maybe safety like curtains. But when they're actually providing a machine with a functional safety in place, they can add different kind of value. So for instance, we can talk about troubleshooting tools, real-time monitoring applications. We can even talk about sending safety information to a cloud and develop a big data strategy based on that. So there is no limit about the value that they can actually deliver to the end user.
And just to add one other thing to what Pam says here is from an OEM perspective, right? Many times they may not have the expertise in-house and they may need to reach out, but also it's important to have that discussion with their end user about their expectations, that they do have a good alignment with that end user about what their safety levels are and their safety expectations, right? And for that end user who's developed a safety strategy, what's that end user's acceptable level of risk or tolerable risk level, because that can actually vary from end user to end user of what counts as tolerable risk. That is one of the things when you talk about functional safety and in the standards, that's kind of a vague, I don't want to say a vague concept, but tolerable risk is a little bit dependent upon end user to end user. I mean, if the end user does it wrong, OSHA will certainly let you know. But what one company may accept as an acceptable risk, another company will say, listen, you can't have that in the factory. So from an OEM design perspective, if they have a customer that has a safety specification, they need to make sure they understand it very clearly, so they don't get down the design road or at the point of equipment acceptance to find out, oh, that's not what we want. We don't accept light curtains. We want hard guarding there, or we want PLE compliance and not PLD, right?
Okay, understood. So we've talked about functional machine safety from the end user and OEM perspectives, but what about the effect of operating environments? Since the operating environments and process and discrete manufacturing industries can be obviously dramatically different, how does that affect machine safety considerations?
Well, that's kind of a complex answer because it operates on a couple of levels, right? So your individual safety devices can be very environmentally dependent. So, you know, a laser scanner, for example, which is kind of a very popular common safety device now that's been used by a lot of people because they're quick, they're easy, right? They're highly dust sensitive, right? So a laser scanner that may work perfectly well in an environment that's a clean room, or say, for example, a very clean factory that you see in all the pictures on the cover of magazines, right? You put that in a factory, say, that's manufacturing drywall or has a high dust environment, that laser scanner is going to trip left and right and not really be functional. Similarly, if you have temperature environments, right, a lot of safety equipment actually does have a temperature rating, and at the higher end of the specs, they either have a decreased sensitivity or decreased lifespan. So the environment is also a pretty important consideration from just the components. But then also when you look at the safety solution that's on that device, the environment is pretty important from kind of I want to say a lower level or a base level, because you have to look at what the environment of the operator is. We had a situation where a customer had done a risk assessment on a piece of equipment, had guarded the equipment properly, but then moved the equipment to another location in the factory. Well, at that other location, there was actually a stairwell right next to the equipment. And so an operator actually would go step up a couple of steps and then was able to reach over the guarding and into the hazard to make adjustments. And so that was something that they hadn't considered about the environment, about abilities, places where the operators could reach over, under, around the guarding, because they could step up on stuff, they could crawl under, right? So, you know, there's kind of two levels there on that whole environment they have to look at. And just assuming that, you know, when you do your safety design or your risk assessment, it can't be done in the abstract. It's actually got to be done in the actual environment the machine's going to operate.
So the important thing here is when we're doing the risk assessment, we need to be in front of the machine. We need to do functional safety testing, understand all the safety devices, how they interact with the machine. And also it will be about the environment and how the operator will be interacting with those safety devices. So environment is quite important for the safety.
Now, earlier, Todd, you mentioned the OSHA standard or various standards related to functional machine safety, and standards are, always a good point of refuge, when it comes to assessing machine safety. But standards around machine safety vary considerably across the globe. OEMs, of course, need to address these standards as broadly as possible to enable them to be able to sell their equipment into a variety of targeted areas. But for end users in the U.S., is OSHA everything they should be paying attention to, or are there other standards that they should be aware of as well?
I am going to punt to the TUV functional safety engineer in the room, Pamela, to answer this question.
So there is some key point. No matter what standard we're talking about, or if we are developing a machine in the US or in Europe, we need to do a risk assessment. That is a common thing that we're going to find across all the safety standards. The other thing is that we have ANSI and ISO, and a good distinction about them is that ANSI is focused on end user, while ISO is for machine manufacturer and system integrators. So having that in mind, we have several different options to follow to develop the functional safety design of a machinery. A good starting point would be ANSI B1119. This is a performance criteria for safeguarding and provide a broad perspective of the different ways we can approach and develop the safety solution and different techniques that we can put in place. And it's such a good safety standard that is even following other regions of Europe and Asia. Important thing is also to remember that there is a harmonization between ISO and ANSI, and that means that at the end, no matter if we are following ISO or ANSI, as long as we decide to follow one safety standard, we are going to be compliant. And the additional point is that if we are talking about sending a machine, for instance, to Canada or Brazil, we also need to have in mind that there will be additional requirements and regulations in place that we need to take care of that as well.
And just to add one point, right? So most of the time, say, for example, you mentioned OSHA. OSHA is not going to tell an end user specifically what to do. Right. Or, for example, several of the laws and regulations in other countries are not going to tell the end user or an OEM what to do. They're going to refer to a specific standard. to be followed. And so, as Pamela mentioned, we're seeing now a lot of harmonization among standards across the world because of this exact challenge faced to OEMs, right? And so, with ISO and ANSI starting to be harmonized, we're now starting to see, for example, Brazil with NR12, which was always kind of a one out on its own. They're actually starting to bring it more in line with these standards to try to tackle this type of issue, right? That everyone's got their own roles.
So, because of this harmonization of standards that you're referring to, is there much real difference in terms of what U.S. buyers will find on the market in terms of functional machine safety compared to what buyers in the European Union or elsewhere would encounter?
So, just as we mentioned earlier, the buyer needs to be aware, right, is that, a lot of OEMs, unfortunately here, if they're selling, even if the OEM is selling in Europe and selling in the United States, right, they're not going to see, and it can even be the same piece of equipment, when the OEM is selling here in the United States, they may not even have any safety equipment on it. It's, that's being driven by market pressures. We are seeing now Europe generally has the strictest standards, and more OEMs are designing their machines to the machine directive and the requirements out of Europe. So we are seeing a movement towards more machines being compliant in Europe. So generally, if you're compliant in Europe, you're generally compliant everywhere. But that's one of those ones you do need to be careful about what the local regulations and standards that are being applied in their region.
Okay. So far, we've discussed functional machine safety from a purchasing and implementation point of view. But what about it when it comes to assessing legacy equipment? How should end users go about assessing the safety of their existing systems and upgrading them as needed?
Yes. So one of the key points here is to define the safety standard that you're going to follow if you're going to be after ANSI, ISO. And after that, you need to do a risk assessment. So the risk assessment here is the key part. We need to understand all the hazards involved. We need to make sure that all the stakeholders for this specific machine that you have in place will be involved. So that means getting operators, management, and maintenance as well involved in this process. When we had the risk assessment results, we need to define the safety strategy that we want to take in place. That safety strategy will depend of the amount of machine that we have, the severities that the risk assessment report shows, and based on that, made a prioritization about which machine will be the main focus in the short, long term. Todd, anything else that you want to add?
Yeah. So, when Pamela was talking about doing the risk assessment and especially doing, like, for example, a plant-wide assessment and understanding your kind of where your greatest risks are, retrofitting safety on equipment isn't cheap. And it's very rare that even the largest companies can afford to bring an entire plant into compliance in a single stroke, right? Or one year, right? So what is key for an end user, right, is understand where they've got the greatest risk to their employees and focus on getting those machines into compliance first, and then kind of work their way down the food chain, right, and to make sure they're allocating their budget wisely. Now, the other hazard, kind of non-safety going on once you start down this road, which is important to do, is that, a lot of end users out there have old equipment and schematics are going to be lost. When there could be a lot of maintenance repairs and patches having been done over the years. And once they go in and actually start to retrofit safety on it, it can be a little bit of, Indiana Jones and the Lost control system, as they open up a panel and there's nothing but spaghetti in there, and they got 6 colors of wire and they're chasing wire. So it is something to be aware of, is that, when you're retrofitting, I always tell end users, honestly, it's going to take longer than you think, and it's going to cost more than you expect. Because you're going to find stuff, and then there's going to be, it's also when if you've ever done a house remodel, right? Well, while we're there, we started to talk about only doing the bathroom, but we could do this, and maybe it's time to put in a new PLC, right? So there are those kind of project management hazards that they need to be aware of once they start doing retrofits of their safety, right? And there can be sticker shock, right? Because you can have a piece of equipment that maybe they bought used at $15,000, or for example, and to bring it into compliance might be another $10,000, right? So that is not an uncommon event, right? So that is can be something that you need to be aware of when you start your functional safety journey.
Okay. Well, thank you for joining me for this podcast, Pamela and Todd, and thanks to all of our listeners. And please keep watching this space for more installments of Automation World Get Your Questions Answered. And remember to visit our website at www.automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.